Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and this week, we are going to add some more cool stuff to Frogger. Um, well, where we left off last week is we added these logs so that Frogger will actually have a place to be safe as he tries to cross the water. So, but the problem is that the frog right now doesn't know that these are logs. They could just as well be water to him, and he wouldn't know any different. So, what we have to do is we have to tell the frog that that's a log, and that because it's a log, he should move at the same velocity in the same direction as the log is moving, so that he continues down his path of safety, right? So how we're going to do this is we're going to do it in a script, of course. But before we start with that, I want to remind everybody to actually, give me a thumbs up. Call it an advanced thumbs up, and if you don't like the video later, you can always give me a thumbs down. That way you won't forget, and it's cool to give me a thumbs up right away because you're so excited. And don't forget to check out my other channel, Code Scruffs, my wife's channel, Donibus Maximus, for some awesome retro gameplay. And check out my Patreon because it's cool to have new patrons because you guys are awesome. And because you're so awesome, you get sometimes a little earlier access to the actual source code before the videos are even released on YouTube. So you get to see all the stuff before it actually gets uploaded and processed. So that's cool. You won't see the video because I don't put those on Patreon, but I do post the source code when I'm ready to upload the video on YouTube. So the source code gets posted on Patreon, and then the video is uploaded probably an hour to 2 hours after that. So if you guys are impatient, you can feel free to hop on over to Patreon and become a member there. $5 pledge is all it takes, and you get full access to all of the source code from now and going forward to all the future source code that I'm going to release for all of the projects that I work on, as long as you continue to pledge. So with that out of the way, let's go ahead and open up the player script. You know what? I do want to say one more quick. There are 100 million different ways, maybe that many, but there are tons of different ways to do exactly the same thing and accomplish the same task. And while one may be more efficient than the other, and it's not always about code efficiency. It's sometimes about code readability and does it even make sense to you? If I can write this entire script on one line. On one line. Get rid of all the white space, even though the white space doesn't matter because the compiler just throws it all out. It would be all in one line. No one would be able to read it. Double space as much as you can. Leave, tabs. Just make sure that your style is your style. If you're working in a team, make sure that you guys agree on a specific style. If you guys are creating variable names and you're working in a team and your team decides, okay, let's use camel case for all the variable names, then make sure you use camel case for all the variable names. Otherwise, you're going to be the odd man out and no one's going to understand what the fuck you're doing. So there you go. That's that. If you think that you can accomplish a task a different way or a smarter way or just a more optimal way, then I would suggest that you do that. That's fine. There's no problem with that. Calling someone's code wrong or incorrect or not the right way to do it or not the best way to do it, I think that that's wrong. If your code still accomplishes what you want it to do, then it's right. It does it, and it works. Could it introduce more bugs? Maybe. It all depends on the final product. If the final product works exactly as intended, then it's fine. It's not like a bad designed car engine, that's going to break down after 10,000 miles. It's a lot better, especially as beginners, for you guys to just discover everything on your own. You know, use my examples as a guide. Don't use them as, you know, set in stone. I'm not writing the next Bible of programming here. I'm just saying that, you know, this is one way to do it. What I do, this is one way you can accomplish it. If you find a better way, find a better way. I don't care. That's completely up to you. If you want to throw a comment on my video and you want to say, hey, you know, I found this better way to do it, and you want to share it with the rest of the group, that's great. I don't care. Just don't call someone's coding style incorrect just because it doesn't suit your needs. That's all I'm saying. What we're going to do in our script is we are checking right here in our check collisions method if basically our object is safe or not. So that's our first step, but we also need to know if the object's a log, right? So in this collidable object, we could create a variable and say, hey, is this a log? Right? So let's just pretend that we've already gone in and we've tagged our logs with that boolean saying, hey, yeah, this is a log. We can now go back into our player script and we can say, okay, well, if it's safe, we say if it's a log, so if collidable object dot is log, okay? So we know it's a log. Okay, so if we're on a log, what we want to do is we want to travel with the log. So, but first we need to figure out what direction the log is going in. And we need to get a reference to our current position. So we're going to create a vector2 and call it position. And say transform.local position. That's what it equals now. And then we're going to say if the collidable object dot get component, we should be able to get the log component, and we're going to say, is it moving right? Oops. Alright, so if it's moving right, we do one thing. Otherwise, we do something else. So if the log is moving right, we want to set our x position. We're going to increment it by the collidable object, which is going to be the log. We're going to get the component, which is the actual log. And then we're going to say, hey, what's your move speed? And then we're going to times that times time.delta time. And that's going to set the new position for the frog. Okay, and then if we're going in the opposite direction, we're just going to do position.x minus equals collidable object dot get component log dot move speed time dot delta time, and that would be that. And then finally at the end here, we're going to assign the position to local position. So what do you guys think? You think this is going to work? I don't know. Let's have a look. Any minute now. There we go. Whoa. Obviously I didn't see that car coming. And no. And because what's going on is we're also still colliding with the water. And and we didn't mark the, see, this is why I always try to do this first. We didn't mark the log as being safe. So to go to these, or we didn't mark it as being a log. All right, so let's do this. And we're going to say is log, because all of these are logs. And let's try that again. Damn it. Nope, still not working. Okay, so we're going to have to do to solve this problem, because what's going on here is the frog is basically colliding with the water and with the log. In our for loop, when we are testing, here, let me show you. So we're in here, we're in the for loop, and we're testing against every single collidable object. So in one iteration, we could be colliding with the water, and in the next iteration, we could be colliding with the log. So if we collide with the water first in this iteration of collisions, then we're going to die. And even if we collide with the log first, we'll eventually collide with the water as well, and we will die. Because the water and the log are in the same, spot. Like, as far as XY values are concerned, or in the same rectangle, all right? So what we need to do is we need to find a way to only, like, if basically if we get a collision that says, hey, you're safe, then we need to basically say that we're safe, and then only then we will die if we say that we're not safe. Does that make sense? All right. So let's do this. Let's create a Boolean just up here where we check for collisions. So we're just going to call this is safe, and we're going to set that to true. And then we are going to go in here, and we're going to say is safe equals true, because obviously we are safe. And here we're going to say is safe equals false. And then we're going to take this line of code, these two lines of code, going to get rid of those in there, and we're going to, after the for each, which is right here, we're going to say if not is safe, then this happens. So what we're doing is we're using the Boolean to check whether or not we're safe. And the Boolean is going to get set to false once, every time that we collide something that's not safe. But when we collide something that is safe, we'll get is safe set to true. The problem with this now is that, okay, so let's say that the first iteration comes around and we say, all right, well, is the collidable object safe? Nope. Okay, so we set is safe to false. Then we get to the next iteration, and let's say that we're on the log, and it's like, hey, is this safe? And we're like, okay, yeah, so let's set it to true. Perfect. So is it a log? Yes, blah, 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 blah. And then the next iteration comes around, colliding with the water, and it's like, hey, we're not safe, so is safe equals false. If not is safe, then we die. So what we need to do here is we need to break out of this iteration, or this actual like for loop. We say, hey, once we're safe, we don't want to test anymore. We just don't. So we say is safe equals true, and then at the end of all of this, after this if statement here, this for the log, we say break. And what break will do is it'll break us out of this for each loop. So we say it's true, then we say break, and then the very next line of code that's going to be run after that is, hey, if it's not safe, then die. Okay, well, it is safe, so we don't care about this, and we're going to just continue on like we were. And that should allow us to sit on the log and happily move along with it. Let's see if that works. I hope it will. I really hope it will. Don't hit me. Don't hit me. Hey! Whoa. Okay, so see what's going on here? Because I don't. Where's the frog? Where's the stupid frog? Do we not name him Frog? Player. He's right here. Ah. So he traveled on the log as far as the log could take him, and then the log got reset to a different position, and the frog just kind of said, hey, alright, I'll just stay here. Okay, So we have to know when the log goes past the green bar, we need to move the frog to the other log. So let's do that. So the frog has to loop with the log. All right. So what we'll do is we'll just say if transform.position.x, which is the frog, minus get component sprite renderer dot size dot x transform.position.x minus get component. So we're subtracting the size of the frog from the position that he's currently at. Should probably divide that by 2. And we're going to say if it's greater than or equal to it would be the width. Would it be? All right. So if it's greater than or equal to the how are we doing the logs? Let's look at the log script to help figure this out. We have play area width is 19. All right, so we want the frog yeah, the half of the play area width. That would probably work. All right, so we would say if it's greater than or equal to 9.5, which is half of the play area width, we would then set his position to be position.x. We would set that equal shit. We would do position.x equals negative 9.5. Actually, we could just do transform.position.x minus 19f, because we'll just move him and divide it by 2. That should move him to the other log. But let's also make sure of something else here. We've got our player at order in layer 2. The log is order in layer 5. These are order in layer 10. So let's make the player be at 6 to make sure that he's actually above the logs. And let's try it. There we go. And we didn't get to come across. What we did, but not in the right location. So if the player is here at 7.5, but the player won't be the X position of the player let's try something here. Let's put, actually let's get rid of this divided by 2. If the X position of the player is greater than 9.5, which is at the edge of the play screen, we want to put the player's X position minus 19. I think the dividing it by 2 is throwing it off. And what I'm going to do here is I'm going to do a split screen so that we can see what's going on. Alright. Give us plenty of time here. Alright, so the frog is about to leave. See, like when it gets to the middle of the frog, he should start to... Well, that's not right. Frog's position is 10. It's definitely greater than or equal to 9.5. Yeah, that was not what I expected to happen. Let's try that again. Okay, come on, come on, come on, come on, come on, come on, come on. The frog is at 8.8, 8.9, 9.3, 9.4, 9.54. See, or should have already teleported. Wait a minute. What am I doing? I don't care about the size. We certainly don't care about the size over here. Alright, let's try that again. This time it should be perfect. Alright. So the frog is at 7, 8, 9.23452. There, at the next frame. He has been moved over to the next log. And he comes around the corner. Now I'm a little worried about this because he's not going to be on the log. Yeah. Alright. And that's probably because we have to add 1 because of the bar. I don't know, something weird is happening. So if he's on this log, and if he's in the center of this log, these logs are 7.5 minus 10.5. What? So that's 11. That's 18. The logs are 18 pixels apart, or 18 units apart, not 19. So I have to subtract 18. Alright, so let's see here. Player minus 18. to put him in the same position of the log where he came from. All right. So, fuck. Just, damn it. There. All right. So we are now at the, we're like centered on the right line of that log. So when we leave the screen and we subtract 18 from our X position, we should be literally in the same position of the other log. So let's see if that works. What is our position of the player? Player position is 5.96. All right. No, 5, 6, 7, 8, 9.56, and the next frame we should be on the log and in the position that we wanted to be in. Let's just make sure that that is continuous. Alright, at this next frame. Okay, so there's a little tiny bit of variance, and that probably has to do with the fractions of a decimal that we are moving with the log. Okay, you understand what I'm saying there? Because every time the log moves, it's possible for us to move a little further to the left. And we can move on the log, which is cool. We should be able to jump to the next one. And the next one. And we should be able to jump back down. And back up. Let's see what happens if we jump while we're in limbo. Oh shit. We didn't do the didn't do the left side. Alright, so let's go back into player script. And let's do the left side. So basically here it's going to be if transform.position.x is less than or equal to negative 9.5. We set the position.x equal to transform.position. Ooh. When do we start working with position versus local position? I don't like that at all. This is where one time where your coding style, or all the times, coding style matters a lot. So if just for like the sake of being consistent, you're not. It's not a good thing to basically switch between local position and position. And most times it's not going to really matter because your local position is going to be equal to your position. But in the rare case that you do something different, it's going to make a big difference. So transform the local position and transform dot local position. Okay. And let me just clean this up a little bit. Oops. Alright, so here we break. And let's save. And let's make sure that everything is working the way we want it to. Here we are on the log, and let's jump to the next one, and to the next one, and we're going to go down, and see if we can, alright. And I died because I jumped into the water, just to make sure that that still works. Okay. And movement is good. All right. Yeah, no, all of this looks great. So I think we're going to end it here. And, you know, now that we've got a way for us to test whether or not we are safe on the log and we can move with the log, I think the next thing for us to implement will be the lily pads. And of course, as you may or may not know, the lily pads are basically the same thing as the log, except the lily pads, they go bad over time. They just kind of like start to disappear. And, you know, so you can only be on those a specific amount of time. And then there's the game timer that actually will tell you, hey, you're done. You're gonna die now. And then there are the lives that we need to actually account for. We can only have a certain amount before it's game over and we start over. And then, of course, we still have to get to the winning part and reaching the actual like win spaces at the very top. So there's still a lot left to do. But I think the next tutorial will definitely be the lily pads. And so I'm going to go ahead and wrap it up now, and I'll see you guys next week. Don't forget to subscribe, hit the bell for notifications, give me a thumbs up if you liked the video, thumbs down if you didn't like it. And again, yeah, I'll see you guys next week.